In this video, we are going to go over how to model harmonic motion of a given real-world scenario. In this question, we've been asked to model the harmonic motion described by a particular scenario using both a graph and an equation. The question reads as follows. Sarah sits down on the edge of a merry-go-round at her local amusement park. The ride has a diameter of approximately 30 meters and can make a full revolution in 20 pi seconds. At what position is Sarah after approximately 15 seconds? We graph this problem under the assumption that Sarah is starting from y equal to 0 when the ride begins and is initially moving in the positive y direction. The first thing we can determine from the given information is that the diameter of the ride is approximately 30 meters. With this information, we can say that the radius is equal to 15 meters. And given that, we can say that the amplitude is equal to 15 meters as well. Additionally, they tell us that the ride can make a full revolution in 20 pi seconds. This gives us the period of this particular harmonic motion. We know it's the period because the period is the time it takes for the graph to make a full revolution. Additionally, from this problem, we can determine that the phase shift is 0 because we know that Sarah is starting from 0. This phase shift, however, only applies under the circumstances that we make our equation a y equals sine type equation. This is because sine at time is equal to 0 is always equal to 0 when there is no phase shift. And now we can give ourselves a graph to work with to begin graphing this equation. Take a moment to pause the video and draw yourself a graph. Now we can begin graphing this scenario by noting that the question tells us that Sarah is expected to start from y equals 0 when the ride begins. So our first point is at y equals 0 when time is also at 0. They also tell us that the ride makes a full revolution in 20 pi seconds, which means she will be back at 0. And during that time, she needs to follow a pattern of harmonic motion, which we will use a sine graph to represent. We know that initially she is moving in the positive direction, and then she will move back down through the 0, reach the bottom of her rotation, and then once again reach the starting point. So we know that right around the middle, she is going to reach the same height on the opposite side of the merry-go-round. And in between the initial starting point and the midpoint, she must reach the top of her rotation. And in between the midpoint and the end of her ride, she must reach the bottom of her rotation. We can now go ahead and graph this function. Once you have graphed the function, we can now begin to answer the question that was asked. We want to know what position Sarah is at after approximately 15 seconds. Given that pi is equal to approximately 3.14, we know that 5 pi is going to be just greater than 15 seconds. So we can place our pencil just before the 5 pi mark, and we expect 15 seconds to be about right there. We can make our way up to determine the y position on the graph, about right here. And then we can make our way horizontally to the y-axis to determine her approximate height. We expect Sarah to be somewhere between 14 and 15 meters based on this position. Now we can write our equation to represent this sine function and use that to verify our answer. The first thing to note is that the amplitude of our function is 15 meters, so we know we'll start with y equal to 15 times sine. We also know that the period is equal to 20 pi seconds, and in your general sine function, we know that the sine of k times x will give us a period of 2 pi divided by k. We therefore know that our k needs to be equal to 1/10 in order to get a period of 20 pi seconds times x, and this is our sine function to represent this harmonic motion. We can now determine her exact height at time equal to 15 seconds by plugging in y is equal to 15 sine of 1/10 times our time of 15 seconds. We can use our calculator to solve this by plugging in 15 times the sine of 1 divided by 10 times 15. And we determined that Sarah's height at a time of 15 seconds will be exactly 14.96 meters. This concludes our video on the modeling of the harmonic motion of real-world scenarios.